Hi, hello everyone. Welcome back to my channel Savvy NX. Today we're going to learn about velocity time graphs. There are 4 different types of velocity time graphs and we're gonna look at all of them. So before we get into today's video, don't forget to subscribe to my channel and click the bell icon so that you'll get a notification as soon as I upload a video. So now without further ado, let's get started. So let's learn the uses of velocity time graphs. There are 4 uses. The first is we can find nature of motion, we can find velocity, we can find acceleration, and we can find displacement using velocity time graphs. So first type of velocity time graph is constant velocity. Now I'm drawing the x and y axis. Time goes here, velocity goes there. And the shape of this constant velocity time graph is a straight line parallel to x-axis. This is because the velocity has equal value, so it does not change over time. So you can see at time t1, the velocity is v1, and at time t2, the velocity is v1 again. So the value of velocity does not change. The second type of velocity time graphs is uniform acceleration. I'm drawing the x and y axis. And the shape of this uniform acceleration is a straight line. So since it's a straight line, the nature of the motion is uniform. So now to find the acceleration in this velocity time graph, how about from acceleration from A to B? To find this, I have to find the value of the slope. Now the slope means this part of the graph from A to B. This is our slope. So you can tell like slope is equal to acceleration and acceleration is equal to change in velocity by time taken. So you can mention this like this. Slope is equal to change in velocity is nothing but initial velocity, final velocity minus initial velocity by time taken. So this is the value of the slope. Now we have to find this in this graph. So the velocity at the point A, I'm mentioning it as v1, and the velocity at point B, I'm mentioning it as v2. And the time, I'm mentioning it as t1 at point A and t2 at point B. So now to find the value of acceleration, we have to find v2 minus v1, which is the change in velocity, and the time interval t2 minus t1. So this is our formula for the slope to find acceleration. So now to find this, I'm going to mention some quantities. For velocity 1, I'll mention it as 2, and then 2 meter per second. At B, I'm mentioning it as 4 meter per second. And for T1, I'm mentioning it as 2 seconds. And T2, I'm mentioning it as 8 seconds. So now we are going to substitute in this formula. So V2 is nothing but 4 meter per second. So 4 minus V1 is 2 divided by, now T2 is 8 minus T1 is 2. So this is nothing but 2 by 4. This 2 by 4 is nothing but 1 by 2 meter per second square or 0.5 meter per second square. Meter per second square is the unit for acceleration. So this is our acceleration value. So we have to find the value of slope to find the value of acceleration. Now with acceleration, we can also find displacement in this velocity time graph. So to find displacement, we have to find the area of this part. This region, we have to find the area. So now to find the area of this part, we can either find the triangle area and then add it with the rectangle area, or we can find the area of the trapezium as a whole. So that time also you'll get the value of the displacement. So now we have completed the 2 types of velocity time graphs. Now let's move on to the third and fourth type. So the third type of velocity time graph is non-uniform acceleration. And there are 2 types of graphs under non-uniform acceleration. The first one is velocity increases with time. So this type of graph, it is in the shape of a parabola. This is the parabola shape. This is because velocity is non-uniformly increasing with time. So the second one is velocity decreases non-uniformly with time. Now you can see that first it is gradually increasing and then there's bend. This bend is because the velocity is decreasing non-uniformly with respect to time. So let's move on to the fourth type, which is uniform retardation. So retardation means velocity decreases uniformly with respect to time. So the graph here looks like a straight line which goes in a downward direction. This is because it is uniformly decreasing with time. So instead of going in the upwards direction, it is moving to the downwards direction due to retardation. So these are all about the four types of velocity time graphs, and I hope you understood about velocity time graphs and the concepts under it. So thanks for watching. Don't forget to like, share and subscribe to SavvyNX. Stay tuned for more interesting videos. I'll see you all in my next video. Bye friends.